T-minus 11, 10, 9, 8, 7, 6, 5. We have engine start. 2, 1.
0.
We have ignition and we have liftoff. Liftoff, 32 minutes after the hour, and the shuttle has cleared the tower.
11. Clear. Roger, roll. Houston confirms good roll program. Standing by for main engine throttle down to control structural loads on Challenger during max Q, the period of maximum inlet pressure. Seconds elapsed. Altitude 1 mile and a half. Throttle coming down to 69%. Altitude 6 miles, downrange 3 miles. Main engine throttle's going back to 100%. Challenger's go at throttle up. Challenger, Houston, you're go at throttle up.
Roger, Houston, we're looking at the moon directly overhead.
Roger that. One minute, 30 seconds, velocity 3,700 feet per second, altitude 12.5 miles, downrange 9 miles. All 3 main engines still at 100%. Standing by for solid rocket booster separation.
STS-8 is complete, Houston.
Roger. Confirm SRB separation. Guidance has confirmed, has converged.
Your first stage performance was nominal.
Boy, Brown, you should have seen it from here. It was daylight almost all the way up.
Well, I'll bet it was.
Challenger Houston, we're getting some good pictures of the payload bay and the American flag on the front of the PFTA.
Outstanding. And it sounds like this comm it sounds loud and clear. You're a little less volume than we were over the previous site, but it's very clear.
Roger, you're loud and clear also.
Challenger, Houston's with you at Hawaii with a good video.
And I guess you're seeing the picture of the middeck. Is that true?
Roger, we're seeing Richard and Bill on the middeck. It looks like Richard's trying to give us a demonstration.
Richard's doing a doctor appointment. You can see that we've all grown some white spots on our foreheads.
Roger, we can see that.
And for those of you who don't know what those are part of Dr. Bill's experiments. There are 3 electrodes, one in the middle of the forehead and one by the right eye and the left eye, which he wires us up when we do our EOG eye movements, so he can record that stuff on his recorders. And that measuring device, you saw Richard
Copy that, Dan.
Okay, in the background, behind Guy, you can see the Cephas. He's right in the middle of sample run number 2. Everything's been going really well on that.
Okay, and Challenger Houston, we've gone ahead and switched the camera to the payload bay now.
Couldn't stand this anymore, huh?
Okay, what you're seeing now is Richard going sailing through the mid-deck, and Dale is getting ready to do his measurement.
And here's the last...
Roger, that's really super.
And here's the last member of our crew that you haven't seen so far. He's the one with the wild hair.
Oh, that looks good, Dan.
And he's showing you how he can eat a carrot. Hands upside down or something. There goes the carrot.
Houston, we're going to get ready and power down the SCA at the end of the ASC thermal test. We're doing that now.
Roger that, we copy.
This Mission Control Houston, STS-8, is now in its second day. Mission elapsed time, 1 day, 0 hours, 0 minutes. Mission Specialist Dale Gardner at the aft crew station.
Okay, Challenger, we see a picture coming down from inside the cabin. Looks like you guys are all in full control there.
Just waiting for the lights to come up a little brighter and I'll give you the elbow, Jeff.
Okay, looking forward to seeing it.
Okay, there you go. You're seeing by the edge of the PFTA and just seeing the port side of the movable part of the sun shield and a little bit of the port side of the stationary part of the sun shield.
Looks like a strange bit of modern architecture.
It does get some. You gotta get used to it looking at it at this angle. And there's the other guys working hard up front. How's that picture now, Jeff? Can you see Guy and Dan?
Both of them are in there, working hard. No rest for the weary.
Okay, Houston, both gimbal checks look good on board. The targets look good. We fixed up the weight and we're ready to go back to 201.
Okay, Dick, we've been watching from down here and everything looks good to us with the gimbal.
Okay. And Jeff, Guy's on the bottom of page 3-6.
Okay, we're watching.
Okay, we're going to 3-7A, inside activation.
We're with you.
Movement. Movement stops.
We confirm it. That's what we see down here. Looks like you've moved out of range of Mila and we've lost the picture. We're still with you through Bermuda for another 3 minutes.
Understand, Houston, and we're putting external power on the inside right now.
Yeah, we're watching the data down here.
Challenger, Houston's with you at Hawaii. The President is on the line.
Yes, sir, Mr. President.
Where are you now?
We're over Hawaii, sir.
Over Hawaii. And coming this
Sir, yes, sir, coming your way at about 160 miles up.
in about 20 minutes. You should be here. Well, listen, congratulations on a successful and a spectacular night launch. Every one of these launches of the shuttle is a spectacular and a noteworthy event, but this one has certainly its share of firsts. I know it was touch and go with the weather, but you were launched right on schedule, and I think about 250 million Americans breathed a great sigh of relief. But you've got a lot of firsts there. And Guy, congratulations. You, I think, are paving the way for many others, and you're making it plain that we are in an era of brotherhood here in our land, and you will serve as a role model for so many others and be so inspirational that I can't help but express my gratitude to you. And then Bill, at 54, is the oldest astronaut to ever fly in space. You have a especially warm place in my heart. And it makes me think that maybe someday I might be able to go along. I know this has been a busy day with the successful deployment early this morning of the Indian national satellite, which I understand will bring a broad range of communication and weather resources to the people of India and serves as a good example of international cooperation in space. But on behalf of all our people, I want to thank you all for your courage, your commitment to space research. You've set a fine example for all our young people who represent our hope for the future. Now, I know that this call came, I caught you on your way to your bunks for some well-deserved sleep, so I'd better cut this short, and I just wanted to let you know that we're all looking forward to another successful mission and to your safe landing here in California on Labor Day. God bless all of you.
Mr. President, thank you so much. We appreciate your taking the time to call us, and we're very pleased and proud to be here, and thank you for calling us very much.
Well, it's my pleasure, and I know I'm speaking on behalf of all your fellow countrymen when I say good flying and a happy landing on Labor Day here in the USA. Again, God bless you. Carry on.
Thank you, Mr. President.
Less than a minute away from reacquisition of Challenger through Hawaii. A brief dropout from Hawaii over to Goldstone. We have data through Hawaii at this time.
Challenger, Houston's with you at Hawaii for 7.5 minutes.
TVs are on. I think we have the elbow camera selected for you first. That might be a good view. And Inco can control any camera he wants except for B. We're using that one for data. And flight deck camera is set up also.
Roger, we understand, Dale. Thank you. And Challenger, Houston, we are receiving a beautiful picture of your sunrise down here. Thanks a lot.
Yeah, we see you watching that.
I'll bet you do. This teeters is really a neat thing.
And we're in one of the notorious 2-minute waits right now.
And Challenger, Houston, we'd like you to take a look at the depth B-17 and confirm the attitude deadband is 0.5.
Okay.
Fish, Dale is listening. He and Thornton are doing something. Go ahead.
simple flashing lights, goes through the optic nerve, up into the brain, and we can literally track these well into the brain itself. Now, there are a number of other items that we have on board, but all of these are aimed at giving us a better understanding of the way weightlessness is affecting the nervous system. And
Roger, Bill, let me say a couple of words, too, if I may. As you can see, the addition to Bill Thornton to our crew just a few months before was a significant addition to the objectives of this mission. Most of the equipment that you've seen and most of the work that he has done has been done by himself, and I can assure you on this flight, despite the INSAT deploy and the work on the CFIS and the work that Dale Gardner has done on the RMS and the PFTA, that the hardest working individual on board has been Bill. Most of the equipment is his, and he really deserves credit for a tremendous research program that he's working in space. Now, we're not quite through, however, with the TV show, and over the months we have had to put up with what we've called Bill's Chamber of Horrors. So we have a little measurement program of our own, and if you'll just bear with me, we'll show it to you.
Roger, we're waiting for it, Rick.
Well, Houston, thanks very much for listening, and hope you've enjoyed the show. See you later.
Roger that, Richard. It was a great show. Thanks a lot.
now having the infrared imaging system picking up the orbiter.
Houston, Challenger ball, state 0.0.
Roger, copy.
9,600 feet. 279 knots.
Challenger Houston, looking good on final.
7,000 feet. 4.5 miles. 290 knots. .4,100 feet, 285 knots, 3 miles. Airspeed 300 knots. Gear down. Gear down. Range 1 mile. And we mark touchdown at 8 minutes 40 seconds.
Houston, give the commander an OK3. Houston, Challenger stopped.
Roger, copy. Welcome back. Great show.
We copied end of roll at 9 minutes 32 seconds, past the elapsed time hour. Challenger crew preparing to come down the ramp to the van. Tires and brakes on the orbiter look good.
Welcome back, STS-8.
T-minus 50 seconds and counting. Hydrogen burn igniters have been armed. T-minus 45 seconds and counting. Solid rocket booster development flight instrumentation recorders going to the record mode. Main propulsion system, liquid oxygen, liquid hydrogen, outboard fill valves have been closed. T-minus 35 seconds and counting. T-minus 31. We have a go for auto sequence start. Challenger's 4 redundant computer is now assuming primary control of critical vehicle functions from now through liftoff. T-minus 20 seconds and counting. SRB engine nozzle gimbal profile now underway. T-minus 11, 10, 9, 8, 7, 6, 5. We have engine start. 2, 1. We have ignition and we have liftoff. Liftoff, 32 minutes after the hour, and the shuttle has cleared the tower.
Clear. Roger, roll. Houston confirms good roll program. Standing by for main engine throttle down to control structural loads on Challenger during max Q, the period of maximum redundant pressure. Seconds elapsed. Altitude 1 mile and a half. Throttle's coming down to 69%. Seconds. Altitude 6 miles, downrange 3 miles. Main engine throttle's going back to 100%. Challenger's go at throttle up. Challenger, Houston, your go at throttle up. Roger, Houston, we're looking at the moon directly overhead. Roger that. One minute, 30 seconds, velocity 3,700 feet per second, altitude 12.5 miles, downrange 9 miles. All 3 main engines still at 100%. Standing by for solid rocket booster separation. SRB-7 is complete, Houston. Roger. Confirm SRB separation. Guidance has confirmed, has converged. Your first stage performance was nominal. Boy, Brown, you should have seen it from here. It was daylight almost all the way up. Well, I'll bet it was.
T-minus 11, 10, 9, 8, 7, 6, 5. We have engine start. 2, 1. We have ignition and we have liftoff. Liftoff, 32 minutes after the hour, and the shuttle has cleared the tower.
Clear. Roger, roll. Houston confirms good roll program. Standing by for main engine throttle down to control structural loads on Challenger during max Q, the period of maximum redundant pressure. Seconds elapsed. Altitude 1 mile and a half. Throttle's coming down to 69%. Seconds. Altitude 6 miles, downrange 3 miles. Main engine throttle's going back to 100%. Challenger's go at throttle up. Challenger, Houston, you're go at throttle up.
Roger, Houston, we're looking at the moon directly overhead.
Roger that.
One minute, 30 seconds. Velocity 3,700 feet per second. Altitude 12.5 miles. Downrange 9 miles. All three main engines still at 100%. Standing by for solid rocket booster separation.
Roger.
Confirm SRB separation. Guidance has confirmed, has converged.
Your first stage performance was nominal.
Oh, Brown, you should have seen it from here. It was daylight almost all the way up.
Well, I'll bet it was.
There's a vehicle on the pad the night of the launch. Unfortunately, you can't see the lightning and the rain. As we depart our quarters heading out to the pad, once again, it doesn't show, but it was raining cats and dogs. And I think each of us in the crew were not real confident that we were going to get off. Here's a picture in the cockpit before liftoff. That's looking over Richard's shoulder. And we got off a little bit late, but we did get to go. And the three main engines started just fine and were running very smoothly. When it was a little bit of vibration in the cockpit, the SRBs lit off and it became very bright, as you can see right here. It was just like day in the cockpit. And all during first stage, we didn't need lights in the cockpit. It was plenty bright. The vibration was pretty much like other crews have explained in the cockpit. During first stage, we were shaking around a little bit, but nothing you couldn't handle. And from reports that people on the ground, they got a pretty spectacular show. From inside the cockpit looking out, it looked like you kind of expect it to look like at the top of this. You were looking into a cloud with a bright light. I mean, it was just a glow all around the cockpit. And once we got up away from the ground a little bit, you couldn't see the ground anymore, and it just looked like you were in the middle of a glowing ball.
Which we were.
Which we were. You can see out the windows there. That's a sort of a representation. Here we're going through, well, you just went through the cloud deck there, which kind of reflected a little more light back in the cockpit now. This is just going through the cloud deck at about 20,000 feet. You can see that the vibration isn't too bad, and we're all in there busily checking our instruments, being sure everything is running properly. The next scene you'll see from the cockpit is when the solid rocket boosters departed, and that was really a bright flash. And after that, there wasn't as much flashing or brightness in the cockpit until the external tank. There's the SEP with the SRBs. That's when those rockets push it away and it really gets bright.
Okay, once we got on orbit, the view from space was just spectacular, and this is just an indication of that just from the cockpit. One of the objectives of our mission was to deploy the INSAT satellite, and this is the cockpit arrangement associated with deploying the satellite. In this particular view, Dan is actually operating the 16-millimeter camera, panning the cockpit. You can see Dick over there on the left. He's sort of supervising the operation. There's Dale. He's going to be handling the cameras and the switches. And I'm working from the commander's seat up front, sending out commands through keyboard and talking to the PAM and a satellite through CRT display. You can see, as I said, that was basically our arrangement. Dan sat in the pilot seat during this operation, sort of monitoring the motion of the vehicle, making sure that it was steady and that there were very few vibrations of any sort. There's a picture of the INSAT actually being deployed from the spacecraft. You can see that the deploy went very smoothly. At the moment of deploy, there was a large thump, and as I said, the The spacecraft was deployed very smoothly, and there were no vibrations or no precession of the satellite as it left the payload bay. Matter of fact, Dale pointed out that about a minute 20 seconds after deployment, you could see some of the jets on the spacecraft actually firing as part of the nutation control associated with the spacecraft. Another aspect of our mission was checking out the TDRS network. And so the shuttle flew various different attitudes during the mission, checking out the KU band. And this is the picture of the KU band antenna that was used to check out the TDRS satellite. We found that the communications were excellent, both up and down, and that's going to be a real advantage for us on future missions.
Another task, of course, was the work with the RMS and the PFTA, the Payload Flight Test Article. In this view, I had the 16mm camera and tried to give you a look at what the RMS, the arm, looks like in its normal berth position. Here it is stowed as it is for launch and entry, and those times on orbit when it's not actually being used, it actually rolls in on those pylons, those mounts that you can see on the bottom. This is a view in the aft flight deck. I'm over at the arm station, and Richard's to the left to fly the vehicle. Here you can see the arm going in towards grapple fixture number 5. Remember, that's the one on the front of the PFTA. You can see here it looks like we're losing the view of the arm as it goes behind the DFI pallet in the front. However, from the cockpit, that was a very comfortable thing to do, and it never appeared to us that we were getting close to contact. This is lifting the PFTA out in direct mode, where I'm moving one joint at a time, again on grapple fixture 5. And here's a shot with grapple fixture 2. A lot of the tests were putting the arm and the PFTA up in various configurations and then putting pulses into the orbiter or into the arm and seeing what the relative motions were between the two. So while we were doing that, of course, we got some fantastic views of the Earth down below, and had the cameras always at the ready to get good pictures. Arm operations were extremely smooth. Richard and I had no problems operating it from the aft flight deck. You can see that we didn't bother to restrain ourselves in any way when we didn't want to, and the whole task was very easy. We did on flight day 5 something that surprised us all as far as the views go, and that is a look at the underside of the vehicle. This task has always been in our repertoire. It's been in the checklist, but we've never had to use it. Dick worked on it some in STS-8 in anticipation of being able to look at tile. Here you can see the view of the underside is extremely clear. And again, these are 16mm movies made off the TV film, so the TV is really much better than this. Here we zoom in, I think, on one of the elevons. This is the port elevon, which is down a little bit, and you can see that with the real VTR film, you're almost able to make out numbers on individual tiles. We're really surprised at the great view that we got with this technique. The arm, of course, was hidden from us. It was down around the bottom of the vehicle, so we really couldn't see it. This series, you can see some vernier jets firing in the back of the vehicle, and after the next one, watch how the vernier jet firings excite the glow around the ohms pod. You can see it there. It gets very bright for a few seconds and then slowly fades away. But even at its dimmest, you can see that you can still see the glow, and it was even more apparent to us with our eyeballs. Here we're setting up for an on-orbit ohms burn. We're getting some things ready in the mid-deck. There's the ohms engines firing out the back, and now watch what happens in the mid-deck. That's 1/16 of a G. Each of the ohms engines is 1 foot per second squared for a total of 2 feet per second squared, and that 1/16 of a G felt like a lot to us after being up there for 3 or 4 days. And you can see the acceleration on the tape. It keeps wanting to go back towards the aft bulkhead because we're accelerating forward towards the left of the screen. This is the final work on one of the Cephas samples. The sample has already been separated. The cells are in individual partitions in that tray. You saw me there shaking the tray to make sure the cells mixed with the nutrient materials that had been previously placed in those cells. I'm now putting the whole collector tray back into a cooler where it remained for the rest of the flight. Bill?
Yes, this is an old man in space taking a walk on his walker. And here we have some of the long-suffering crewmen being subjected to a variety of studies looking at various aspects of the vestibular control system. The electronics there work very well in that mode. It's rather simple, but I would compare the quality of the records and such that we obtain to those of labs on Earth. This is another aspect looking at how well one can coordinate eye and hands in a complex tracking task. There were, then finally, I guess most of you have seen these, in which you turn your head while you track both the head and eye motion, which again allows one to see how well the eyes are capable of tracking and how they're affected.
These next few scenes just show some other activity. You'll notice how clean the middeck is. We kept it this way the entire flight. Now, actually, I'm going down there to change the cabin temp controller, which is underneath the middeck floor. And you can see just by floating and an occasional toe leaning up on something that you can do your work. And it's one of the reasons in zero gravity and on orbit that people can work such long hours and not get tired. It's just a delight to work in that environment. This is a little scene on preparing a meal. Each of these each is an individual food tray, and we've had. You'll see here in a moment we've had several calls for guys for Major League Scouts looking for infielders. But generally, after a couple of days on orbit, we found that one or two of the guys could set up a meal for all of the crew in just 8 or 10 minutes, and it was quite convenient and provided a really nice way to stop work for a little while and have a hot meal. It was a lot of fun. This is, as a task, about twice a day we had to change the lithium hydroxide canisters also underneath the middeck floor. We had a shopping list of just engineering duties that we had to perform that we've on each of the flights we're trying to record just so that training for future crews can go well, and this is an example of one of them. These canisters are used to scrub the air so that it'll be clean and easy to use. You notice this is that the seats, except for the commander's and the pilot's seat up on the flight deck, the mission specialist seats for ascent and entry are dismantled after you get on orbit, and they're very difficult in 1G and very heavy to manhandle to install. So this is real time. We set up a camera, or at least Dale and Bill and Guy did, and in about 2 minutes from the time they untaped the chair until Dale had strapped into it and was sitting there was just a couple of minutes, and it's just a good example of how easy it is to work in zero gravity. That kind of ends up our own orbit part of the film. Now we're going to talk briefly about the entry and landing. This is 16mm photography taken by Dale of the front windows. Again, you can see the glow, which now is orange in color. And as we described before, these are the pulses taken by Dale by holding a camera and looking aft and above his head, above the tail. We have, and this is real time, incidentally. This pulsing is happening at the frequency that you're seeing it. It is not understood at the moment. We've shown it to the thermal folks, and it's going to take a little thinking to describe what it is that we're seeing. This is probably a little long for the press conference. We left this entire sequence in so that our engineering friends could take a look at it. One last shot panning of the cockpit with the glow. As it started out changing colors, up high it was sort of a salmon color and finally got white hot. This is the landing as seen through an infrared camera that was out at Edwards, transported down there from the Navy Weapons Center at Channel Lake. You'll notice it's infrared, so actually the vehicle was not visible to anybody that was there at this point. The brighter areas are the hottest, and so you can see the red hot or white hot nose cone there. And if you look carefully, you can see that the window areas are also hotter. It's so good that you see the gear deployment, and you can see that black area are actually the cold rubber main tires. And we defy Hollywood to match this sequence. This is the Challenger coming in for landing on runway 22 at Edwards. You'll see us kicking up a little bit of dust off the runway surface. There's the touchdown, which was fairly smooth, and all I can say for the landing is my hat is off to the people that helped us develop the heads-up display and the night lighting system, and to the great work that was in support for the last year, generally in the middle of the night, to the folks out in our shuttle training aircraft that provided Dan and me with the training that it took to accomplish this first night landing. Finally, at the end, here's the crew holding on for dear life to the rails to make sure they don't embarrass themselves walking down these steps, but actually by now, everybody was readapting quickly to 1G. And I hope this movie portrays to you the fact that we had a lot of fun on the flight, because if it does, it was certainly accurate.